As we go on to section 4 of chapter 2, it's Introduction to Problem Solving. A thing to keep in mind as we continue to work on chapter 2 is, what are the 6 steps in doing an equation? So I'll have these up, but these are something you ought to think about. Step 1, get rid of fractions, whether they're regular fractions or decimal fractions. Get rid of grouping symbols, parentheses, division bars. Collect like terms. And you're going to transpose. Get all of the letters to one side, the variables, all of the knowns, the numbers, to the other side. Then you're going to solve for x, either by taking the reciprocal or dividing by the numerical coefficient of x. And then check your work. In doing Math Lab, when you're doing the practice, you don't need to check, because by putting it in there, it tells you if you have it right. So that's a little benefit. Okay, so going on here, what's our strategy? Well, we're going to look for key terms. Let's pick some out here. So twice means 2 times. Added, we're going to do a sum, is the same as, that was the equal sign, then we have subtracted from a number. Well, our number is going to be our variable. Now often when you do a problem like this, you have to read it more than once to gain mastery of what they're trying to ask you to do. So let's start off. This one's sort of an easy one. Twice a number added to 7 is the same as 3 subtracted from a number. Now you don't put the 3 first here. We had gone over that. Here's the number, subtract 3 from it. So there is your basic equation that we got pretty much from just translating for English into algebra. Now we have to solve it. Well, again, there's no fractions, there's no grouping symbols. We have a variable, a number, a variable, a number. That's sort of where we would be after we collected like terms. So now we're going to transpose. Well, we want our n's to be positive, so I'm going to subtract an n here, subtract an n there. This leaves me with just an n. Or move this n over to this side, it becomes a negative n. And now we're going to transpose this. This will become a -7, so -7, -3 is -10. Now you'll notice I'm going to start leaving out steps, but if you need to include these steps, be sure to do so, because you want to get the right answer. But you want to eventually be able to speed things up by not doing all the steps physically. You do some of them mentally. So here we transpose the n, we transpose the +7, and that gives us our answer. Now if we put, just to check it, a -10 where the n is, this becomes the -20 plus 7 equals a -10 minus 3. Well, this is a -13 equals a -13, and it does, in fact, check. As we go on to example 2, again, read it carefully. Twice the sum of a number and 4 is the same as 4 times the number decreased by 12. So once again, we're looking for like key words. Twice. And here it's twice a sum. So here's where it gets a little bit tricky. How do we show the sum of a number and 4? And the answer is we put it in a parenthesis. And then we know that is the same as, is equal. 4 times the number, that's pretty straightforward. Decrease, that's subtraction by 12. Okay, we should have enough, but again, you may have to read it again and try to understand what they're asking. So twice the sum, twice the sum. I need those parentheses to indicate a sum. The sum of this, if you only went 2n plus 4 without the parentheses, then you wouldn't be saying twice the sum of this is the same as 4 times the number decreased by 12. So no fractions, but there is a grouping symbol. So 2n plus 8 equals 4n minus 12. And again, we want to transpose at this stage, since you don't have to collect any like terms. Want to keep our n's positive. So I'm going to move the 2n to this side where it becomes a negative 2n, or add negative 2n to both sides. I'm going to add 12 to both sides. That'll give me here a 20. And then I'm going to divide now both sides to isolate the numerical coefficient of x, and we get n equals 10. Had a phone call coming in and I just couldn't catch it in time. So once again, it's probably useful to go over this. Twice the sum of a number and something. You're going to get this frequently. And again, this calls for a parenthesis to make this a sum. This part was straightforward. But then getting rid of the grouping symbol, because if you had just said 2n, this would end up being a 4. You didn't include this as a sum. And this is the answer, and it checks out. In example 3, and again we're on page 106, I've made it a little shorter. If you look at it in the textbook, you get a lot more detail and a lot more insight into the strategy of doing it. But here you have a 48-inch board of balsa wood that is to be cut into 2 pieces, such that the longer piece is 3 times the shorter piece, 3 times in length as the shorter piece. So what strategy? Well, again, you may read it again. You know that you have a 48-inch board, so you might want to make a little picture of that 48-inch board. So there's the total length. Now you're going to cut it, and there's going to be a short piece and a long piece. So let's say this is the long piece and this is the short piece. And now you're going to put information into that. This, well, do we know what the short piece is? And the answer is no. So let's use the letter S for the short piece. Now, what do we know then about the long piece? Well, it says it right here. It's 3 times the shorter piece. So this piece we now know is going to be 3s. And we know that 3s plus s is going to equal 48. Now here's where you have to remember there's a 1 in front that we don't write. We're going to group like terms. We're now going to isolate the s by dividing by the numerical coefficient. Remember, what we do to one side, we must do to the other. So s is going to be 12, and 3 times s will be 36, and 36 plus 12 equals 48. Now, you might have been able to do this by just thinking and using empirical skills, but by doing the algebra, it allows you to use the techniques that are very useful when you get to more difficult examples. Now, in our legislative branch of the government, we have a House of Representatives and a Senate. Well, the House of Representatives have a total of 435 seats. There are 49 fewer Democrats than Republicans. How many do we have of each? Now, there's a couple of ways to set this up. And again, looking at the book, they'll give you a lot of background, a lot of suggestions, but what's a strategy? Well, we don't know the number of Republicans. So let's say Republicans are a certain portion of that House, and it's the majority as it is right now as well. Now, how many Democrats are in the House? Again, we don't know that, but we know it's this many less than the Republicans. Now, this total is going to be 4. So see if this makes sense. So this is the number of Republicans, this is the number of Democrats, and this is the total seats in the House. So what do? Well, we start to collect like terms. Here we have a 2r. We have to transpose that, and that's going to give us a 484. And now, what do? Well, we want to isolate the r, so we're going to divide both sides by 2. So we get the Republicans are 242 seats. And what will the Democrats have? Well, they're going to have 49 less than that, which will be 193. And if you add these two up, they now check out as 435 seats. So again, not too difficult. There could have been a way in which you said, well, the Democrats would be D, Republicans would have been R plus 49. So again, but this is a pretty good way. and you want to have a way that you get success and you understand what's done. But keep in mind, there's often more than just one way to do something. In example 5, it's over 2 pages, and it deals with the Vietnam Veteran War Memorial, the walls. In fact, I went there, and it's a very sad place to be, but we are honoring those who have gone before us and made the ultimate sacrifice. Let's get back to our math. If you were to connect the 2 walls that are there, they would form what is called an isosceles triangle. And you may recall that the base angles of an isosceles triangle are the same. And they're telling us, as we read the problem, that this, if they were joined, would be 97.5 degrees more than the base angle. So in our textbook, and here I've made a picture of an isosceles triangle where I've put in the information they've given us. Base angles are the same, and this other corner is 97.5 degrees more than the base angle. That you would pick out of the text. Now, the other thing you would need to know about any triangle, that the measure of the triangle, so we did have another phone call, and it looks like I left my pointer out there. Okay, so in setting up the equation, then it would be x plus x plus x plus this. We get 3x, collecting like terms. Now we're going to transpose this to the other side by subtracting that from 180, and we get 82.5. Then we're going to divide by 3, and we get our base angles are 27.5 degrees. And then this other angle up at the top, when we add this to the 97.5, gives us 125 degrees. So the key about this is they're introducing you to, or reviewing, isosceles triangle. Base angles are the same, and that triangles have a total of 180 degrees. In example, actually this is example 6, we want to do a little background review of consecutive numbers. If you have numbers that are consecutive, and if this is the first number, 5, then 5 plus 1 is 6. 5 plus 2 is 7. And again, this is for any 3 consecutive numbers. Now, if you have an even or odd consecutive number, the first number, again, it defines itself by whether that's even or odd. The next one, you add 2, and the next one, you add 4. So these are the first 3 of any even or odd consecutive integers. We had done that in an earlier lesson as well. Now, in some states, area codes are odd numbers. So they're asking that in this particular state, there are 2 consecutive odd integers as area codes, whose sum is 1,208, or 1208. So here the key is two consecutive odd integers. So what will the first one be? X. What will the next one be? X plus 2. And again, if this is odd, this is 7, x plus 2 is 9. By adding 2, you get the next even or odd, depending upon what you start with. And the sum is this. So we collect like terms. We transpose the 2 by subtracting it from both sides. We divide by 2, and we get 603. Now, if you say 603 is the answer, that's going to be wrong. 603 is part of the answer. They wanted to know what were the area codes. So 603 is the first one. You add 2 to it to get the 605. And then you've met your required answer in a sense. You put all parts of it there. And if you add those up, they add up to 1208.